we have this state diagram. State 1, your output is 0. Or state 1, yep. State 2, your output is 0. State 3, your output is 0. State 4, your output is 1. State 5, your output is 1. And state 6, your output is 1. If you put a 1 for an input, you stay there. If you put a 0, you go to state 2. If you put a 1, you go back there. If you put a 0, you go down here. If you put a 1 from this one, you go back there. If you put a 0, if you put a 0, if you put a 1, if you put a 0, 1 up, and where's my 0 going? 0 going down here. I don't know, I'm just drawing lines. 1 going back there. And 0 going, I don't know, 4. Is that messy enough?
Don't we have 2 zeros on 6?
On 6? Oh yeah, I guess got excited there. On 6. I'll make it go to 4 since that's less to erase. Shorter line to erase. I use less of this. Yeah, I guess I get too excited there. There we go. Anything else? I have 2 of them. So how many states do we have? 6 states. How many flip-flops? 2 to the n has to be less than or equal to 6. N has to be, 2 to the n has to be greater than or equal to 6. So n has to be what? Minimum 3. You need 3 flip-flops. Q1, Q2, and Q3. You have 3 flip-flops. So maybe state 1, I will label it as what?
0, 0, 0.
Want to make it 0, 0, 1 and make 0, 0, don't care? It's up to you. So I can make state 1, 0, 0, 1, that's state 1, that's S1. 0, 1, 0, that's S2. 0, 1, 1, that's S3. 1, 0, 0. 1, 0, 0 is S4. 1, 0, 1 is S5. 1, 1, 0, S6. 1, 1, 1, that's 7. We don't have 7. What do you want to make it? Don't care. And what about 0, 0, 0? Don't care. You can give them any notation. You can decide S1 to be 0, 0, 0, but you did the designer. You decide. So if you did 0, 0, 0 as S1, then you're going to have 2 don't care on the bottom. I can also make a reset, meaning what? Go to state 1. Anytime you find yourself at these cases, go back to 1. The way it's set up right now is going to go anywhere it wants to go. I don't care what happens when you find yourself here or here. It shouldn't be there. It's not going to happen that often. So it's up to you how you decide what you want to do with them. So let me make, so we know we have actually 3 inputs, Q1, Q2, and Q3. We also have X as our 4th input. So I have 4 inputs here. So let me make my state table now. That's the current state. Q1, Q2, Q3, my input, which is X. Where's my eraser? I mean, my ruler. That's you. And let's list all the combinations. You can have 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1. Next one, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. Next state, that's Q1 star, Q2 star, Q3 star, and my output Z. We said if you are 0, 0, 0, what's your input? I mean, that's the state you should not be. So you're going to go what? Don't care, don't care, don't care where you go? Yep. And I don't care what you do for output. If I'm a state 0, 0, 1, that's this one. And you put a 0, you go to state 2. 0, 1, 0, your output is 0. If you put a 1, you go to where? 0, 0, 1, your output is 0. If you are state 2 and you put a 0, you go to 3. 0, 1, 1, you get nothing. If you put a 1, you go to 0, 0, 1, you get nothing. This is state 3. If you put a 0 in it, you go to 4 and you get a 1. If you put a 1, it goes back to state 1 and you get nothing. If you are state 4, you put a 0, you stay there, and you get 1 for an output. If you're at this state, you put a 1, you go to 5, and you get 1 for an output. 1 here. Next one, you are state 5, right here. You put a 0, you go to state 4. And you get a 1 for output. You put a 1, you go to state 6, and you get 1 for an output. 6 is what? 1, 1, 0, and you get a 1. If you are state 6, you put a 0, you go to 4, and your output is 1. If you put a 1, you go to state 1, and your output is 0. And the last two states are don't care. We opted to go with don't care. Now I'm using don't care. Now we need to decide what kind of flip-flop we're going to use. I can mix and match just to be different. So maybe for the first flip-flop, I will use a T flip-flop. So for the first one, I'm going to use T. T flip-flop, toggle. The second one I'll use D flip-flop. And what do you want to use for the last one? JK? SR? JK? When did you come in?
Before you?
Before me? Really?
Yeah.
Oh. You know I'm not feeling good, so that explains. Okay. Color coding here comes in handy. Makes it easy on my eyes. Let me look at the first one. Okay. So again, the excitation table for a T flip-flop, T for toggle. If you go from 0 to 0, that's no changes. T is 0. 0 to 1, T is 1. 1 to 0, that's a toggle. T is 1. So if the next state stays the same, you get a 0. If it switches, you get a 1. So let's put them in. 0 to I don't care. I really don't care. 0 to 0, staying the same. T is 0. 0 to 0, T is 0. 0 to 0, T is 0. 0 to 0, T is 0. 0 to 1, T is 1, that's a toggle. 0 to 0, T is 0. 1 to 1, that's the same, T is 0. 1 to 1, T is 0. 1 to 1, 0. 1 to 1, 0. 1 to 1, 0. 1 to 0, that's a toggle. T is 1. 1 to don't care, don't care, don't care. So it's only going to have a value of 1 if you go from 0 to 1 or 1 to 0. The next one is the D flip-flop. The good news about the D flip-flop, usually D is whatever the next state is. So you don't even have to look at this. It's called data flip-flop, so it's going to be whatever you have here. And the last one, I'm using the JK flip-flop. That's Q3. I picked those intentionally, so I'm not spending too much time looking at the chart. But this one I have to look at the chart because I don't remember it. Again, here's my excitation table, so I don't have to keep putting two sheets on top of each other. For JK flip-flop, Q and Q next. This is what J should be and this is what K should be. 0 to 0. J should be 0, K don't care. 0 to 1. J is 1, K don't care. 1 to 0. Don't care for J. 1 for K. And 1 to 1. Don't care and 0. We wrote them down last class. It's a table that looks like this for all of them. I'll snap this and put in the notes so you can print it. So now let's look at this. 0 to don't care. That means like 0 to 0 or 0 to 1. It's don't care and don't care. Because if you look at 0 to 0, 0 and don't care. And 0 to 1, 1 and don't care. So this is don't care and either 0 or 1. That's where you don't care. and don't care. 0 to don't care, and don't care. Now the next one, 1 to 0. What's 1 to 0? Don't care and 1. 1 to 1. Don't care and 0. 0 to 1. 1 and don't care. 0 to 1. 1 and don't care. 1 to 0. Don't care and 1. 1 to 1. Don't care and 0. 0 to 0. 0 and don't care. 0 to 1. 1 and don't care. 1 to 0. Don't care and 1. 1 to 1. Don't care and 0. 1 to 1. Don't, yep. Was that 1 to 0? I might.
Yeah, 1 to 0.
1 to 0. Don't care and 1. That was 1 to 0. Zero to 0. 0 and don't care. 0 to 1. 1 and don't care. 1 to don't care. That could be 1 to 0 or 1 to 1. If you look at 1 to 0, don't care and 1. 1 to 1, don't care and 0. So don't care and don't care. And now it's going to do a K-map for each one of these. A K-map for each one of these. 1, 2, 3, 4, 5. I can do a K-map for Z, K-map for T, D, J, K. Or I can decide to have fun with them. You know what? Let me have fun. For T1, I want you to use a 16 by 1 decoder. Actually, I should have made it, you know what, for J3 and K3, use a 16 by 1 decoder. How about J3 and K3? Use a 16 by 1 decoder. Not 16 by 1, that's a 4 by 16 decoder. For T1, I wanted to use a 16 by 1 mux. For D2, use an 8 by 1 mux. And obviously some gates here. This one just 16 by 1 mux, this is 8 by 1 mux. And for Z, what should we use for Z? Use a 4 by 1 mux? I'm not even simplifying them. And gates. And some gates. Or plus gates. This is not the AND gate, like, you know, we have AND and OR. That's not what I meant by that. That and also gates. That could be AND and OR. That's good. That will make it easier. So here's my design. I'm going to have three actually flip-flops. I'm trying to figure out what's the best design is going to be. This is the first one. Can you see that, the first flip-flop? Here's the second one. And here's the third one. God, this is cool, huh? Look at this. Op amp, circles, everything. Ricardo gets amused by little things. Okay. This is number one. Number one flip-flop is a T flip-flop, so it has one input, T1. It has two outputs, Q1 and Q1 naught. The second one is a D flip-flop, so that's one input, D2, that means 2 for the second flip-flop. It has Q1, Q2 and Q2 naught. And the last one's a JK, has two inputs, J3, K3, and it has two outputs, Q3 and Q3 naught. Let me start with the JK, the last one, because I'm using from top, J3 and K3. So also I'm going to have a clock going to each one of these. So that's the clock going to all of them. And let's see what's going to it. It says use 4x16 decoders. I'm going to have 4 inputs going to that one and 16 outputs coming out of it. So here's the first one. Boy, this is like squeezing things in. So I'm going to have a decoder, which is a chip now. And it has 4 inputs. Well, my inputs better be what? What are my inputs? Q1, Q2, Q3, and X. I'm not going to run the wires to it. You know what you're supposed to do. X is the external input. There's my external input right here. And this is the complement of that, so available. So this is X. So you're going to attach X, Q1, Q2, and Q3, all the way to that. Remember, the way this actually works, there's an enable here. I'm going to make sure that enable is on. I just go on, enable, and I want that to be on. Now, to be on, that means could be low, could be high. It depends on the chip we're using. That's EN for chip enable. It should have 16 outputs. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. I'm squeezing it there. So now for J3, that's this one. You need to attach an OR gate and put the ones going to it. So I only have 1, 2, 3, 4 ones. Can you see the 4 ones? So I'm going to take an OR gate here and attach to that which one? 0, 1, 0, 0. That's 4 and 5. 4 is attached to it. 5 is attached to it. What else is attached to it? 4, 5. I have to it 1, 0, 0, 1. 9. And 1, 1, 0, 1. Is that 13? 9 and 13. If you can see that. 4, 5, 9, 13. For K, I'm also going to have another OR gate. And this OR gate is going to have attached to it pin number 2, pin number 6. So 2, 6, 10 and 11, I think. 10 and 11. So this flip-flop is connected. I'm using 4 by 16 decoder. Now for this one, I'm going to use a mux. 16 by 1 mux. Again, here we go. 16 by 1 mux. It has 16 inputs, 1 output, 4 control signals. I have to go higher. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I need to go 15, 16. That has 16 by 1. That means 1 output. And again, the enable for that, I want it to be on. Let's say this is enable. I want it to be on. And my control signals on the top, there's 4 of them because you have 16 inputs, are what? Q1, Q2, Q3, and X. And I got to decide which one of these is going to be attached to VCC, which one of these is going to attach to ground. Attached to VCC, I'm talking about the D flip-flop. I really could care where you attach the first and second. See that? But I need pin number 0010. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I need pin number what? 2, 4, 2, 4, and this one is 1, 0, 1, 11, right? 2, 4, and 11. 2, 4, and 11 attached to VCC. 2, 4, 11. and the rest of them to ground. So maybe I'll make my life easy on me and I'll go like this. I'll put a ground here. The rest of them to ground. I changed my mind about the ground there. I put it down there because I realized I don't have a space there.
Did you know it's connected to D?
Huh?
Did you know it's connected to D?
This is connected to the D input, yes. The output. Is that what you're asking?
I don't understand why.
Well, you have one output, right? So you want D here to have these values. So when you put 0, 0, 0, yep. When I'm putting 0, 0, 0, D is going to have whatever attached to 0. In this case, I decided to make that a 0 just to make my life easy. I could have made it 1 or 0 that don't care. I decided to go with zeros. Now for T1, I'm using 8 by 1 mux. So that's smaller one. So that means I got to be creative. 3 inputs to it, 8 by 1. Maybe right here. This is 16 by 1 mux. This is 8 by 1 mux. Eight by 1. I'm squishing everything there. And what's going to be attached to that? That's for T. Let's look at T. That means I have to look at 2 at a time. Well, the first 2, I don't really care what you attach to it. 0 or 1. Doesn't matter. We'll decide that later. The next 2 is going to be attached what? When you have 0, 0, 1. And 0, 0, 1, you're getting zeros. So you want to attach, I didn't decide on the first one, but this one has to be attached to ground. So let me make this a ground. And since I'm at it, maybe I'll make the don't care ground too. So this one attached to ground, that's 0, 1. What about when you put 0, 1, 0? That's 2. It's twice here. This is what X is. You see 0, 1? And what's T is going to be? 0, regardless when it's 0 or 1. That means it doesn't matter. How about 0, 1, 1? Again, I have 3 control signals. My control signals are what? Q1, Q2, and Q3. So when Q1, Q2, and Q3 are 0, 1, 1, that's a 3. There's 2 of these cases right here. Oh, let's look at that. Nope. Look right here. When X is 0, T1 was what? 1. When X is 1, what happened to T1? That's the complement of X. That's X naught. Now let's look at the 1, 0, 0. That's these 2 cases, 1, 0, 0, both of these. I can block what's above it so you know where to look at. So this is where the 1, 0, 0 starts. When it's 0, I got a 0. When it's 1, I got a 0. That's ground. Then the next one is what? 1, 0, 1? Let's look and see what the 1, 0, 1 is. Right here. Let me line up this. And look at this. When it's 1, 0, 1, I got a 0. 1, 0, 1, I got a 0. That's also ground. 0, 1, 2, 3, 4, 5. I still have 6, 7, and 8 to connect. Let's see what's going to 6. That's 1, 1, 0. Is the first one 0? There's no 8 because you're going 0 to 7. Okay, 1, 1, 0. Let's look at it. Where's the 1, 1, 0? When it's 0, we got a 0. When it's, oh, I'm looking at this one. I'm sorry, the orange one, right? Right here. 1, 1, 0. When it's 0, I got a 0. I look at these two. When x is 0. When x is 1, I got a 1. That's x. And the last one, don't care, right? So I'll ground it. And that will drive this flip-flop. Now I need just to create one more gizmo for my output. I want a 4x1 mux. Let's do my output here with 4x1 mux, and maybe some gates go into it. I don't know how many gates. I have 4 inputs, 0, 1, 2, and 3. So I got to look at it. My control signals are Q1, Q2. I always use the most significant. That means the ones on the left. So when they are 0, I got to look at 4 at a time. Let me block this. And let me block this between them. 0, 0. Can you see what this one is? What Z is? Don't care, 0, 0. Since you don't care, the easiest thing to do is make them all what? 0. So I'll make that a ground. The 0, 1, the next 4. 0, 1 begins here. And it ends right here. I want to have a value of 1 when what? When you have 1, 0 for Q3 and X. Can you see that? Otherwise it's 0, 0. 0, 0, 1, 0. So when Q3 is 1 and X is 0, I want to have a 1. How about an AND gate with Q3 and X bar? So if I do an AND gate, Q3 and X bar to it, that will give me that. Now the next one is 1, 0. The next 4. Oh, here it goes. Does he teach? Ambassador. Notice it's always a 1. VCC or 1. And the last one is the last 4. 1 and 1. Well, if you don't care about these, you can make them zeros, right? If you make them 0, you only want to get a 1 when Q3 is 0 and X is 0. Put an AND gate with Q3 not and X not. And that's my design for this. I opted to do this instead of doing K-map because I know I got to do a K-map for each one. And the other part of me is saying, review. Review multiplexers and decoders, basically, how they work. I could have done that with PLA, PAL, ROMs. I might do the next one with You know, ROM, PLA, PEL, whatever. Mix and match. Not today. I got a migraine headache and I gotta go to a meeting. So I'll stop with the video here.